Next example has to do with the French 17th century philosopher René Descartes, who was, of course, remembered because he said it in French. I think, therefore I am, right? Or something to that effect. There are different translations to what he said. One curve that that he came up with, named after him, is called the folium, or the leaf. Folium is leaf in Latin, folium of the card. Okay, so the folium of the card I think it's spelled D-E-S, I think. D-S-C-A-R-T-S, if memory serves me right, is the following curve, is the following relation. It looks like x cubed plus y cubed equal, in this case it would be 6x times y, but in general it would be 3a times xy. A is just a number. Okay, and what we need to do, we need to find the derivative dy dx. There is a little story behind that, but before I tell you the story, let me just show you how it looks like. It has an asymptote. It has a diagonal asymptote, not at the diagonal, a little bit below that. This will be the asymptote, and it comes from the asymptote like so, pass through the origin, but it passes through the origin twice. Loop around here and go back like so. Okay? So it passes through the origin twice. The axis of symmetry is y equal x. This is the axis of symmetry of this leaf or folium. So this is y equal x. But this is the relation. Now, to make it an explicit function, you need to break it into 1, 2, 3, 4, 5 different parts to make it, each piece will be an explicit function. And this is really very inconvenient. René Descartes was, said he was a philosopher, but also a mathematician, of course. Another something that named after him is the Cartesian coordinates, the xy or rectangular coordinate system he came up with. But also he played with calculus. He was trying to find the tangent of a curve. And he challenged a contemporary of him, Fermat, who is known from Fermat's theorem and also was one of the fathers of calculus, although Leibniz and Newton are considered to be both the fathers of calculus. Some people also include Fermat, especially French people, include Fermat as one of the fathers of calculus. So he challenged Fermat and said, you know what? I cannot find the tangent to this curve. Can you find the tangent to this curve? And of course, Fermat, who already played with calculus, came up with it very quickly. Why? Because Fermat knew how to find implicit differentiation. Remember, this is at the time where calculus was not really established yet. All the rules and all the good stuff was not available as it is available to us now. All right, so let's look at it quickly. I don't know if we can. We'll have time to solve it. It's not that bad. I think we can solve it right away. So this is what Fermat did to Descartes. He said, okay, not a big deal. We're going to do implicit differentiation. That is, we're going to take and we're going to apply d dx to everything. Like so. So, on the left side, Here we need to work real carefully. The derivative of x cubed is 3x squared. The derivative of y cubed, first with respect to y, will be 3y squared, and then it will be dy dx, right? And then on the right side, we have the product rule, u and v, where u equals 6x and v equals y. So the derivative of 6x is 6 times v, which is y, plus 6x times the derivative of y. Well, the derivative of y is y prime, or dy dx. Now, since I'm trying to solve for dy dx, on the left side I'll keep all the terms that multiply dy dx. Well, that will be 3y squared minus 6x. So those are all the terms that are multiplying dy dx. On the right side, I'll write the three terms, 6y minus 3x squared. Okay? And then, now I see that I can factor 3 from either side, right? So I divide everything by 3, and I have y squared minus 2x times dy dx equals 2y minus x squared. Notice the symmetry here. Like x and y are reversing the roles. And finally, the solution dy dx will be 2y minus x squared over y squared minus 2x. So Descartes could not come up with this derivative. Of course, he didn't know. He just started thinking about the tangent to a function. Fermat was a little bit ahead of him, and Fermat was able to come up with this. And for us, in our 21st century education, this is really easy stuff once we get the hang of it. Of course, this is something that you see for the first time, so it will take you a little bit time to get more proficient with this. All right, but this is the idea. We'll continue with that on Wednesday. Take care, guys.